Problem number 27. A block in the shape of a rectangular solid has a cross-sectional area of 2.7 centimeter square across its width, a front to rear length of 11.7 centimeter, and a resistance of 435 ohm. The block materials contains 5.33 multiply 10 power 22 conduction electrons per meter cube. A potential difference of 35.8 volt is maintained between its front and the rear faces. We have 4 questions. First question, we are going to find what is the current in the block, and the second question is, if the current density is uniform, what is its magnitude? And the third question is, what is the drift velocity of the conduction electron? And the fourth question is, what is the magnitude of the electric field in the block? So we have 4 questions. First of all, better we can write the given first. And what is given in the question? You have a conductor which is in the form of a rectangular solid block. And this solid block, across its width, its cross-sectional area, what is the value of the area here? So across its width, its area they mentioned is 2.70 centimeter square. If you convert this in terms of meter square, we'll get 2.7 multiply 10 power minus 4 meter square. And from the front side to the back side, its distance. So let's we take that distance is the L value, okay, which is 11.7 centimeter, and in terms of meter, this is 11.7 multiply 10 power minus 2 meter, and the resistance we have here is 935, because this is a conductor, for sure it have the resistance. And in this rectangular block, which is a solid conductor, for sure it will have the conduction electron. So how many conduction electrons you have in this volume of the rectangular solid? You have 5.33 multiply 10 power 22 conduction electron per meter cube. And you set the potential from the front side to the back side of this solid block, the rectangular solid block, how much potential you are giving? We are just giving the potential of 35.8 volt. By using all these informations, we are going to find the answer in the first part. So let's we just write the information about what we are going to find. In the first question, we are going to find the value of the current. In the second question, we are going to find the value for the current density. And the third question, we are going to find the answer for the drift speed of the conduction electron, which is V suffix D. And in the fourth question, we are going to find the answer for the electric field, which is capital E. So we are going to find the answer for these 4 questions. So first of all, let's bring the diagram in front of our eyes. And here you have the block is in the rectangular solid block. So I will draw the diagram. So we have a rectangular block. Okay. And across its width, its area is mentioned, which is 2.7 centimeter. And the most important thing, this is our front side and the back side is the rear side. Am I right? From the front side to the rear side, what is the length? The length is 11.7 centimeter. And from the front side to the back side, you are just setting the potential. How much potential we are setting? From the front side to the back side of this rectangular block, we are just giving the potential of 35.8 volt, and the resistance of this block is 935 ohm. And then how many conduction electrons we have in this volume of the rectangular solid block? We have the conduction electron number as 5.33 multiply 10 power 22 per meter cube. Meter cube means in this volume of the rectangular block, we have this many numbers of conduction electron. Clear? So now we are just going to find the answer for this 4 question, and for that we are going to use these values, right? Okay, first question, we are going to find the answer for the current. So what is the formula for the current? The formula for the current is, we can get the answer for the current from the equation V, which is equal to the current multiplied by the resistance, right? If you rearrange this equation, we can re-modify this equation in terms of current. Therefore, current I, which is equal to V over R. And we have the values for the potential as well as the resistance. So what is the potential you set from the front side to the back side of the solid block? We said 35.8 divided by the resistance of the block is 935. So let's see what is the answer for this question. Okay, so 35.8 divided by 935, I got the answer as 0.0382 ampere, because the unit for the current is ampere. So this is the answer for the first question. So what is the answer for the second question? The second question, we are going to find the current density. So what is the formula for the current density? The current density formula is current divided by area. So here I am going to take the answer of the current from the first part. I am going to substitute here. So if you substitute the value of the current, 0.0382 divided by, across its width, what is the area? The area is 2.7 multiplied 10 to the power of minus 4. So 2.7 multiplied 10 to the power of minus 4. Let's see what is the answer for this current density. 0.0382 divided by 2.7 10 power minus 4. I got the answer here as 141.48. And what is the unit? The unit for the current is ampere, and in the denominator we have the area, so the unit for the area is meter square. So this is the answer for the second question. So answer for the first question is this one. The answer for the second question, current density, is 141.48. And third part, we are going to find the answer for drift speed. As we already studied the relations connecting the current density and the drift speed, which is J equal to NVD multiplied by E. What is this N? N stands for number of conduction electron, and VD stands for the drift speed, and here E is the value of the charge. So, and J is the current density. We already studied this equation. Now I'm going to use this equation for finding the answer for the drift speed. So I have to rearrange this equation in terms of drift speed. Therefore, drift speed VD, which is equal to the current density divided by N multiplied by E. So here for the current density, I am going to use the answer for the B part. So current density value is 141.48 divided by the conduction electron. In the question they gave the value of the conduction electron. How many conduction electrons we have? 5.33 multiplied 10 power 22, and the charge value is 1.6 multiplied 10 to the power of minus 19. Because it's a conduction electron, we just take the magnitude of the charge. So 141.48 divided by 5.33 10 power 22 multiply with 1.6 10 power minus 19. So I got the answer here as drift speed, which is equal to 0.0165. And what's the unit here? The unit here is meter per second. If you want to write the answer in terms of power, we can just write this value as 16.59 multiplied 10 power minus 3 meter per second. Or you can write 1.659 multiplied 10 power minus 2 meter per second. You can write any one of the answer. All these three answers are right. Clear? Okay. Now in the fourth part, we are going to find the answer for the electric field. As we already studied the formula for the electric field, electric field, which is equal to the potential divided by the distance. Here the distance is nothing but the length. So therefore, the potential is 35.8 divided by the distance. So here V over L. So distance is nothing but the distance between the front side to the back side. So here it is 11.7 multiply 10 power minus 2. So the answer for the electric field is 35.8 divided by 11.7 10 power minus 2. So I got the answer for the electric field as 305.98 and the unit is volt per meter. So this is the answer for the fourth part. Clear? That's it. Thank you.